Hey guys, so in this video I'm going to be describing how an automotive car battery works and basically what its purpose is for. So, basic purpose of a car battery is to start the car. Now, it also can do a few other things such as store memory when your car is turned off, and it also actually powers most of your circuits. But in the automotive world we kind of talk about that as that's your alternator. When your car is running, your alternator runs all the circuits, and when it's turned off, the battery does it. So, what really is doing it? That's why I have a picture here of what one of my automotive instructors used to teach us on this. Is basically you got a beer keg. When your beer keg is your battery, and up here that's filling that beer keg is your alternator. So when you are discharging something, when you have a circuit on, you're kind of taking it out of the tap and it's coming out and powering those circuits. If you look at a lot of wiring diagrams for car manufacturers, a lot of them show the positive side of the battery. It shows that it's coming from the battery. So at this time, when you're kind of taking beer out, however much beer comes out, that kind of beer comes in. So it's kind of how your system works. It creates the electricity at the alternator and fills it in and goes into the battery and then comes out your circuits. So you can kind of be the judge on which one is it coming from. I mean, it's coming from the battery, that's coming from the alternator. So which one does it come from? Basically it kind of comes from both. And again, your wiring diagrams are going to show the battery inside of them. But in the general automotive world, we say your battery mainly starts your car and your alternator is the one that does the work when it's running. But let's say, for example, I take out this charge right here. Now it's no longer filling it up. Maybe you have a bad alternator in this case. Your battery can still power all these circuits. But once this keg becomes empty of beer and there's no beer left, you have no more power to power your circuits. And basically you end up with a dead battery. So again, is it coming from the battery or is it coming from the alternator? It's coming basically from both. Now, automotive car batteries are known as flooded lead-acid batteries due to the electrolyte being in liquid form, which I'll get into a little more detail here. Basically, in between the cells you have liquid. If you ever hold a battery and you kind of shake it, you can hear that liquid inside. That's what the electrolyte is. It's that being in liquid form connecting the cells together. Now, over here I have a generic picture of a battery as a whole. Now, car batteries are 12 volts, but it's not one big giant 12 volt cell. It's actually 6 cells that are lined up in series at 2 volts each, and that equal a total of 12 volts. And we line them up in series so you can add up that voltage. Because it goes from negative to positive, that adds up all the voltage. If these cells were lined up in a parallel from positive to positive to positive, and also negative to negative to negative, and even though there's 6 of them, it would still be 2 volts. So that's why we line these up in series to add up all the power of all the cells and make, again, 12 volts total. Now, over here is a more zoomed in version. This is basically one of these cells. And inside the cells you have 2 different type of metals. And as I say here, each cell has 2 sets of electrodes, positive and negative. Which these are the electrodes. They are 2 different types of chemical material, and the positive one is known as the cathode, and the negative one is known as the anode. Now these are meshed together. They don't touch. They're just meshed in between with each other, as you can see up here. And they're connected again in series, positive to negative. And so when they mesh between, what's connecting them together is, again, that electrolyte. Which, as stated here, these plates soak in a chemical bath that is made up of 65% water and 35% sulfuric acid. And that acts as a connection between these 2 plates. The electricity will flow through them. Then we come up here to, which is basically a more generic form of this. It kind of shows, again, the 2 different type of materials. So we have the anode side, which is the negative, and the cathode side, which is the positive. And like I said, it's in between the spaces that connects them together is the sulfuric acid and the water. Now, when these things are going on, they're not creating electricity. That's one thing not to get confused with batteries. The alternator creates electricity. What's going on inside of these is it's transforming that back into electricity, from chemical energy into electrical energy. And it does that by when a device is connected. So again, in this video, I'm going to be talking electron flow, even though in the automotive world we use positive and negative. This one I'll be talking about electron flow, because we're talking about electrons and how they're going to flow throughout the circuit. So when a device is connected, chemical reactions occur inside of here, and that causes the electrons to flow. So because electrons are a negative charge, they will be magnetically repelled away from the negative or the anode side, go through the device, and be magnetically attracted to the positive side of the circuit. And that is essentially what discharging is. Chemicals on the anode release electrons, and the cathode accepts them. So when we are charging it, it's the exact opposite. And charging does the work of pushing the electrons in the opposite directions. So when you charge something, it's not easy. It's work being done. Your alternator is what charges your battery, and it's being driven by the belt on the engine. And it takes work, because when you're doing that, again, electrons are a negative charge, and they flow. You're pushing them in the opposite directions. So because these negative charge electrons are on the positive side, basically what you're doing is you're taking two like magnets and forcing them apart, while also on the other side you're taking two like magnets and repelling them, or you're pushing them together. So that's why it takes work to do that. You're basically charging. Your charge is doing the opposite of discharge. It's a chemical reaction that's going on inside these. So that's basically what goes on, as I stated here. It's doing the work of transforming it. You cannot store electricity. Electricity is the flow of electrons, but you can store electrical energy in chemical form. And that's what this is all doing. It's taking electricity that's created by the alternator, and is storing it in a chemical form, and it's transforming it. That's what it does. It transforms it after it's created. It transforms it into a chemical form, and then when you're using it, it transforms it from that chemical form back into electrical energy. And again, here, you're not creating electricity. It's simply transforming these chemical energy so that they can be stored. Because again, you can't store electricity. So that's one thing not to get confused with all this stuff. You're not creating the electricity in all these cells. You're basically just transforming electrical energy into chemical energy, and then from chemical energy back into electrical energy so that you can store it. That's basically it on how a car battery works. Thanks for watching, and please subscribe.